This is Advanced Math, Unit 12, Lesson 7. You will need your notebooks out, of course, something to write with, your Unit 12 packet, and a calculator. Exponential growth and decay. Okay, our exponential growth or decay function is y equals ab to the x, where a is the initial amount, and we've talked about that before. It's always that first term after your equal sign. B is your growth rate or decay factor. Remember, if it's bigger than 1, it's a growth. If it's smaller than 1, it's a decay. It's never negative. So when it's smaller, it has to be between 0 and 1, and that's a decay. If it's bigger than 1, it is a growth. Okay, and x is time, and y is the amount after given time. All right, number 1. I am going to do homework notes, so I'm just picking these problems right off of your worksheet 7. Number 1. The median price of a new home in Fresno, California in 1975 was $58,000. In 1990, the price was $113,000. It has a bunch of information here. A is just asking us to find the growth rate. Find B. And I am going to do it a little different than what the worksheet, it's the same thing, it's just I'm going to plug it in a little different initially. Find B, the growth rate. And we know it's growing because it says, if you look back at your paper, in 1975, the price was $58,000. And then in 1990, the price of a new home was $113,000. So you can see that it is growing, so our B should come out to be bigger than 1. Okay, so we plug it in here. A being the initial amount, that's the $58,000. Y being the ending amount after given time, that's $113,000. B is what we don't know, that's what we're looking for after the given time. From 1975 to 1990, X is 15 years. That's given to us. It doesn't say it, but we can count between 1975 to 1990. So to the 15th power. And we're solving for B. So we're going to divide both sides by 58,000. Plug that in your calculator. And when you plug it in, you get 1.948. I'm going to put ... because I don't want to round it, but I don't want to have to write the whole number. Just leave the big number in your calculator. Equals B to the 15th power. And we're trying to solve for B. B is the base, so I want to get rid of that 15th power, so I raise both sides to the 1/15th. Y 1/15th, so it'll cross out with the 15, and then this here is what you plug in your calculator. That long decimal should already be there. Just hit exponent 1 fraction 15. If you're using your division key, you do need to put parentheses around your exponent. If you don't want to worry about the parentheses, use your fraction key. Plug it in, and it should come out to be bigger than 1 because it is a growth rate. We're going to round to 3 decimal places, 1.045. That's part A, question A. Question B asks us, write a yearly exponential equation to model this function. That part's easy. We already found B. So the function's going to be y equals A being the initial amount, and that was 58,000. B is our growth rate, 1.045, raised to the x time. This is a function, so we can find the price of a home at any given year. And this is with the starting year or starting time. I'll go ahead and put year. Starting year being 1975. So we can find the price of a home 20 years ago, 20 years from now, 30 years ago, 30 years from now, starting from 1975. That's it for B. Question C. According to this information, what is the median price of a new home in the year 2000? In the year 2000, how much time has passed between 1975 to the year 2000? That is 25 years. And you just plug 25 into X. Y equals 58,000, 1.045 raised to power. Go ahead and plug that in your calculator. This is what it looks like after you plug it in. I know you may not be able to see it, but you should know how to plug it in your calculator. Gosh darn this lighting. Okay. There you go. And that is $174,315.20. Okay, letter D. And they want you to find the price in 1955. Making note, our starting year is 75. So if I'm going to 1955, I'm counting backwards. So this time X is going to equal a negative number, and that's counting back 20 years. So X is negative 20. Y equals original equation, this one here, $58,000. Times our growth rate, 1.045, raised to the negative 20th power. Go ahead and plug that in. And if you're having problems plugging it in, please make sure you ask. And you can ask in class. Okay, it's not coming out for me. I worked it out earlier, and I'm not sure if I wrote something down wrong. 75, because earlier I got $28,049.29, and right now I'm getting something else. And I'm just checking the answer really quick. Nope. I just wrote it down wrong earlier. Sorry. Okay, so it's right. $24,049.29 is the median price of a home in 1955. Okay. So that's the kind of problem you're going to see on the test. Maybe not as many parts. So let's take a look at number 2 from the same worksheet. In 1950, the population of California was about 10,586,000. In 1962, the population was about 19,517,000. Okay, 1950, California's population was approximately 10,586,000, and in 1962, the population was 19 million, approximately 19,517,000. A, write a yearly exponential equation to model this information. In order to model the information, to write the equation, I need to find B. That's always the first thing. They didn't ask that this time, but I always need to find B. And the population is growing, so it is going to be a growth rate. Okay, so y equals ab to the x, y being the amount after given time, 19,517,000, a being the initial amount, 10,586,000. B, we don't know. How much time has passed between 1950 to 1962? 12 years. Go ahead and divide. Okay, plug it in your calculator. Again, don't reduce it when you plug it in. So I'm going to get 1.843 dot 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 equals b to the 12th power, and you raise both sides to the 1/12th power. Leave that number in your calculator. B equals 1.052, and then you write your equation. Y equals 10,586,000, because that's your initial amount right there. And B we just found to be 1.052 raised to the x power, where starting year is 1950. All right, I'm going to have you do part B on your own. This is the answer for part A. Here's the function. Part B is asking us to find, according to this information, what is the population in the year 2000? So figure out what is X. If you started in 1950 to the year 2000, X is 50, and plug it into this function. Write this out again, with 50 being your X, plug it in, get an answer, and we will check it in class together. So that is it for this lesson.